Hello, today's presentation will be about Micro-ISV software development. The presentation is brought to you by the Kentucky Innovation Network, with offices at Morehead State University, Eastern Kentucky University, Ashland, London, and across all of Kentucky. The Innovation and Commercialization Center provides services to technology and innovation-based companies throughout Kentucky, assistance with funding, patents, business creation, and more. The ICC is the driving force behind TechBase 10, creating a network of IT professionals, businesses, and technologists in Kentucky. To learn more, visit the Kentucky Innovation Network at www.kyinnovation.com. To learn more about TechBase 10, visit www.techbase10.com. To speak to someone about the ICC or TechBase 10, contact the MSU ICC at 606-783-9536. I'll be your presenter today. My name is Jerry Travis Smith. I'm the founder of Prosum Tech LLC. I've been programming professionally for 7 years, and you can learn more about me by clicking the link you see there here. And I received a great deal of input from another developer named Mike Bryant, the founder of Mill Creek Software. He has 16 years of paid programming experience. To learn more about Mike, follow the link provided here. This presentation serves to answer questions that people who want to get into developing software may have. What is an ISV or micro-ISV? What types of software can a micro-ISV create? What tools do micro-ISVs need to create products? How can a micro-ISV get their software in the hands of customers? What are some ways to make money from software as a micro-ISV? And finally, how can I learn to write software? Defining a micro-ISV. We're going to start with the definition of an independent software vendor, or ISV. ISVs create software that uses or runs on top of software created by other companies. In other words, you're not starting from scratch. You're stringing together tools and maybe creating things that make those tools work together in order to get a working solution. Some examples are creating an app that runs on an iPhone or Android. Those two are mobile platforms, and you are not responsible for creating those if you are an ISV. You write the app that actually does something useful for someone. You may want to build a website using Windows Server and SQL Server. This, too, is not inventing the technologies from scratch. Rather, it's stringing them together to make something that works. Or creating a desktop app that runs on Windows 7. All of these things make use of products put out by other companies that you take and bend to your will to get them to solve a problem for a customer. ISVs treat software like Legos. They stack and combine all these existing pieces until they get something that solves a problem. A micro ISV is simply an ISV with 10 or fewer employees. And that will be the focus of this presentation. While we hope that this presentation can get you started into becoming a huge software enterprise if that's what you desire, there's absolutely nothing wrong with being a micro ISV because you can thrive in almost any market if you position yourself right. If you know your limitations and you know what you're good at, you can make plenty of money being a micro ISV. Please understand that micro ISV does not mean dinky, generic, cheap, useless, or flimsy software. Quality software has nothing to do with the size of your company. You can specialize in one niche or take on a wide variety of projects as a micro ISV. We want you to know the sky's the limit. It's all up to you to come up with a really good idea and then do something to create it. The micro ISVs are kind of vulnerable in certain situations, such as patent litigation or onslaught of competition from larger firms. If you have 10 or fewer employees, chances are you don't have a team of lawyers just sitting and waiting to fight some big threat. Okay, there's plenty of advantages and disadvantages to developing as a micro ISV, and you'll find in the world of technology, everything is a trade-off. The advantages are low overhead. Your payroll responsibilities are going to be relatively low if you have 10 or fewer employees. You can ramp up on projects very quickly, and what ramp up means is basically get started very fast on a project. That means that you can distribute and communicate the requirements of a project very quickly to all your developers. And it's basically because there's very little bureaucracy. If you need to talk to somebody in a micro ISV, you usually just get up and walk over to their office or over to their cubicle and start talking. There's no need to set up appointments, go through secretaries, or any of that in order to be able to talk to the guy you need to talk to. And there are examples of many successful, which means profitable, micro ISVs. And you can follow these links given here to read about some of the success stories. Now the disadvantages. Limited resources. You have low overhead, as in, a payroll commitment. However, you may not have the money to go out and buy equipment or specialized software you need to get a job done. There also is a limited amount of time given the limited amount of people you have. And then there is the sources of expert knowledge that you may not have. We're going to talk about certain types of software shortly, and you'll see how that having an in-house person with a certain set of skills can be very handy. However, a micro ISV may not be able to afford or have a need to constantly have someone on staff with a skill set you may only need temporarily. Patent or legal clout. If a big company decides to come after you in a patent dispute, even if it gets overturned and ruled in your favor, it still could be very hard on the company financially because micro ISVs generally do not have a huge amount of capital or a big legal team. Most products must be limited in scope. Okay, you're not going to create something huge like an enterprise resource planning system that takes hundreds of developers and millions of lines of code. It's just not going to happen. The quality is still going to be there. Remember, I said micro ISVs create useful software. They just may not create software with as much breadth. Now, there's a lot of different types of software a micro ISV can create. You have custom one-off, commercial off-the-shelf, also known as COTS, niche and micro-niche markets, and games. This is technology, so we know it has advantages and disadvantages regardless of which type you choose to create. Something I'll come back to throughout this presentation is rule number 1. Good software always solves a problem. If you find yourself creating any software of any type that is not solving a problem for customers, you don't need to be creating it. You need to make sure your software solves a problem. Rule number 1. Custom one-off software is often the best type for a micro ISV to get into at first. And that's when you write software for a specific customer. And it's not really meant to be sold repeatedly. Now, usually when you do custom one-offs, it's going to incorporate some very specific business intelligence that may not be relevant to any other company. They might have some process they do that no one else even worries about or nobody else does it the same way. And you must be willing to learn about the various processes, procedures, constraints, and so forth that affect that customer. I worked on a project a while back that required me to know about the various hunting seasons in Kentucky combined with the different zones that had different hunting seasons within the zones. So there was state hunting seasons, then there were some local hunting seasons. We built logic into this application to ensure that what the hunters were booked to hunt, whether it be deer or elk or what have you, was actually legal for them to be hunting during the time that they had booked. That is definitely not a type of business logic that I expect to find in another project again. One of the big advantages of writing custom one-off software is that you generally only have to work with a few people from within the client company. Usually you have one contact or maybe a small team of contacts who work with their company, and then they bring requirements, concerns, and so forth to the developers. It's very expensive to maintain people within a micro ISV just for the sole purpose of communicating with clients. So as mean as it may sound to some people, it's actually a good thing that you don't have to talk to a lot of people. A big problem with one-off software is that when you're done writing the code for the client, it's not really going to help you very much in the future. Sometimes programmers reuse bits and pieces of code that they've done for other projects. With one-off software, most of the stuff you create can't be reused in any way. It is possible to convert one-off software to commercial off-the-shelf. However, it's not a very easy thing to do, and in a lot of cases, it's just as fast to start over with the intent of creating COTS. Let's expand a little bit on the advantages and disadvantages of one-off software. First are the advantages. Your features only need to satisfy one customer. That's a big deal. You don't have to add anything special beyond what they need. So you're not developing things that aren't going to be used. Another big one is that the environment in which the software is going to work is known. So you know what kind of computers they have, what operating systems they're using, and even stuff like how technically savvy are the employees that are going to be using your software. As we've already discussed, you only have to deal with a limited number of people with custom one-off. Another thing you'll find is that smaller one-off projects are readily available in most places, and that's because a lot of companies are just now getting certain business processes online that they've been doing the quote-unquote old-fashioned way for quite some time. And this can provide a quick inflow of cash for other development activities. And that can be a really big deal when you're trying to grow a micro ISV. Now, the disadvantages. There is limited earning potential because the solution most likely will be fairly custom. And sometimes your market size is literally just that one client. Now, I'm not saying that you can't make a good living doing this, but you're not going to become the next Microsoft developing custom one-off software. And we've also discussed at length the limited transferability of knowledge. You may spend a great deal of time learning stuff that's only going to be good for one project. The single point of failure, to me, is the biggest disadvantage of doing custom one-off software. Let's say midway through the project, a customer runs out of money, goes bankrupt, gets in a car wreck, goes to prison, you name it. In other words, something bad. You're going to be standing there holding on to a bunch of code that is of no use to you or anyone else, and you're not going to get paid for it. There is that single point of failure in getting paid. Let's turn our attention to commercial off-the-shelf software, or COTS. These applications are written with the intention that many customers will use them. You're going to write it once and then sell or license it many times over. You don't create a COTS solution unless you know that the market is large enough to support such a venture. Competition can be a big problem with COTS because if you think the problem is worth solving for a lot of companies, other software companies probably will think that problem is worth looking at as well. In young markets, there is inherently going to be a lot of COTS floating around. For example, when personal computers first came out in the early 1980s, there were 70 or 80 different word processors available during that time period. Now we're dwindled down to 2 commercially available word processors. When you're building a COTS solution, you need to make sure there are enough customization options in the software so that customers can get the experience that they need at their specific company. With custom one-off, this isn't really an issue, but with COTS, it's usually not one size fits all. For example, if you're going to do an accounting package software, you would have to worry about offering cash and accrual accounting options because some companies use one, some companies use the other. If you don't include that customization in there, you're probably cutting off a rather large market segment. And as the number of customers increases, so do the support and maintenance demands. So COTS presents a new set of problems that you didn't see with custom one-off. COTS has a lot of advantages. It can be extremely lucrative. And if you don't believe me, look around at most large enterprise software providers because they started out as micro-ISVs with very few employees, and they're some of the largest companies in the world now. You're not dependent on one company to buy your product or pay for support or maintenance. So COTS eliminates the single point of failure problem that you have with custom one-off. The multiple sources of income can allow expansion of your micro-ISV very quickly. It's a lot easier to buy equipment or hire new people and so forth if you have a lot of customers buying your software. There's money to be made. And also, since you're selling to a bunch of companies, you're going to have increased visibility in the market through hopefully positive word of mouth. COTS definitely has some big disadvantages. If you don't provide those customization options, you will alienate a large portion of your market, and providing customization options is not always an easy thing to do. Competition's always going to be a problem in COTS because problems big enough to be solved for a bunch of different companies provide an opportunity for a lot of companies to come in and try to make some money. There's always more of a chance of litigation, being sued for damages or patent infringement when you have a successful COTS solution. In the late 90s and early 2000s, there was a company called SCO that went after all sorts of software companies, big and small, and it was just a real pain. A lot of the things that SCO was suing over ended up being overturned, but it's still very expensive even if you win. Support or maintenance needs may not scale very well, so you have a lot of customers all of a sudden, and you have a lot more support and maintenance requests. It's going to be really hard for you to hire people to keep up with that sometimes. And this is a big one for any large COTS package. Since there's more people using your software, when you do mess up, it gets noticed very fast. And that can be hard on the ego of some micro-ISV owners. Niche and micro-niche software provide a great opportunity for a lot of micro-ISVs. And it's software that sits somewhere between one-off and COTS because you're not dealing with a one-time custom solution, but you're not dealing with the potential for a huge market base. And micro-niche software especially solves a very specific problem for a small group of customers, and you'll usually find that in specialized industries. There is limited growth potential because these niche markets are usually not large growth markets. There is relatively little threat of competition because it's just not a very big pie. So if it's a small pie, a lot of companies won't flock to it. However, if you can corner the pie and grab the thing for yourself, your customers will be very loyal, especially if you're the first one to the punch. And there's plenty of examples of niche and micro niche software that I've heard of. One was a equipment maintenance tracker for breweries. How many breweries do you know of? I mean, there's some, but there's not many, and it's a market that's not really growing very much. Some beekeeper management software, or an app for that, as they say. This is not a huge market, but there are beekeepers. They're very important, and they like to track stuff with software. And there's also this category of niche and micro niche software that is worth looking at for some companies. And it's middleware for products that aren't used very much anymore, such as Real Media or Lotus Notes. Companies like that that are still around probably will be for a long time. However, it's not in huge demand, but for the customers that actually use this stuff still yet, it's extremely important that they have somebody that can write software to make it work for them the way it needs to work. Let's examine more closely the advantages and disadvantages of niche market software. You do have multiple customers, so there isn't exactly a single point of failure. There might not be a huge amount of fallback business, but you will have at least some. There's a low threat of competition because the pie is small. Therefore, it's not going to draw in a bunch of companies trying to take over your niche. You still only have to deal with a limited number of contacts. Now granted, it will be more than the one-off software, but you're not going to have hundreds of support requests and feature requests per day or per month. Now the disadvantages. There is limited growth potential. Most of these niche markets are growing slowly, if at all. You are going to be working in potentially unknown operating environments. Some customers may use one operating system, some customers may use another. Not all industries are homogeneous as far as the computer technology that they use. And this is a big one for niche markets. Disruptive technologies can single-handedly draw up your customer base. A great example of that is you have Netflix and Redbox now that have absolutely decimated video rental stores, and thus the need for the software that you would use to track your video rentals. Sadly, that is only one example of niche markets that get wiped out. And we go back to the limited transferability of knowledge once you leave the niche market. It's not as bad as custom one-off, but it's not really something that you can count on. And I put game development in its own category because it's inherently different than the other types of software that we've talked about. It is an extremely fast-growing market. Over the last few years, games have made more money than Hollywood has with its movies. Now, the types of games that you would develop for mobile do not make near as much money as the big titles, like for a PS3 or an Xbox or something. However, there is money to be made. 72% of the App Store revenue comes from in-game purchases. And this is all an estimate because Apple does not release this information. But if you follow the link there was a analyst that gave this estimate. It is a very saturated market. Right now in the Apple App Store there's 100,000 games. Gamers do have a lot of choices, and believe me, they're very fickle. They will switch if your game starts to disappoint them. It's no big deal. And one thing you really need to keep in mind with game development is it is a different skill set necessary than that of a business app. Somebody with an information systems degree like myself does not have the graphic or media design skills or the level design skills that would be necessary to make a good game. Basically, you have to have people that are technical and good gamers that understand what makes a good game. And if you're going to make a game, you need to realize that it requires a much larger user base to make money, because gamers, especially in the mobile space that's growing so fast, will only pay so much for a game. Whereas a PS3 or an Xbox title might sell for $60, the most expensive mobile game that you'll ever see is $20, and the majority of them are 5 and under. So that's something you need to keep in mind. It's going to take a huge number of people playing your game to make a lot of money. Before we start talking about ideas for software, I want you to keep in mind that I didn't say anything about which type of software that a micro ISV should develop. I can't answer that for you. In fact, no one can but you alone as the owner of a micro ISV. And that's because I don't know how much risk you're willing to assume, or what your competencies are, or what your background is. You have to decide what software that you're going to create that's best for you and your situation. And that does lead us into, how do you find ideas for software to create? Well, I think the absolute best way to figure out an idea for some software is solve a problem for yourself that other people might have as well. And the link I have there is to a story about how Google News came to be. There was an engineer at Google that, following 9/11, decided that it would be a good idea to write a piece of software that could aggregate news that mentioned the terrorist attacks. And somebody at Google says to him, hey, what if we could set it up so you could search for keywords for any news that you were interested in? And that's how Google News was born. And I think he only spent like a month getting the prototype working well enough to put into beta. And one advantage of solving a problem for yourself is if you have a personal investment in the problem, the solutions that you crank out are often of higher quality. And that's because you care on some emotional level and are willing to go just a little bit farther than you may otherwise. My favorite way of coming up with ideas for software is to talk to people. Mike and I and some of our friends sit around and talk all the time about softwares that would provide solutions to problems that we have, or we know that people have, that we know that software would be good at fixing. So talk to your friends. Business people are excellent to talk to because anybody in business is generally concerned with making money. If they're concerned with making money, they usually want to do things more efficiently. A good piece of software will almost always improve some type of efficiency. Forums on the internet are a great place to find ideas for software. If you visit a forum very much and there's a lot of people complaining about something or asking about how to do something, chances are there is a market for that type of software. I have a friend who races at dirt tracks and drag strips, and there's a guy on one of his forums that wrote some software that tracks the point totals for race car drivers. And he got the idea because so many people were asking for something like that on the forums. And he sat down over a month's time and wrote this software. Now he's getting $500 a whack out of it, and from what I can tell, he's doing fairly well. And you can hit up job sites and see what types of job postings there are from companies, and if a lot of companies are posting a job for a type of software developer, then maybe you could make a COTS package that would meet this need and sell it to them. And like I said, this is all just ideas. None of these is going to be a silver bullet every time, but if you do enough of it, you'll stumble on some stuff that works pretty well. Build a good network of smart people, and software ideas will find you. Seek out people who are like-minded, that have that entrepreneurial spirit. Talk to them, hang out with them, kick around things that bother you. Sometimes those things can be solved with some good software. Build a good network of smart people, and good ideas will end up finding you. Seek out people who are like-minded, that like to dream and think of things that are a little off the wall, because sometimes that leads to some pretty big breakthroughs. Make sure to read as much as you can in the news and in the tech magazines, the business magazines, and so on. Reflecting on things you read will often lead to pretty good ideas. And always think very big and then scale back to reality. I've had plenty of ideas that were just awesome, but they were just too big to take on. That doesn't stop me from thinking about stuff like that, though, because sometimes you can find a happy medium between totally awesome and just practical and doable enough to actually make some money at it. Let's talk about marketing as a micro ISV. And I'm really not going to give you anything that is totally prolific. There have been total books written about this subject. But what I am going to do is get you thinking in the right direction as to how you can go about getting your micro ISV noticed. First thing I would say is when you're trying to kick it off, take on as many doable projects as you can. If you can't find any good ideas or any custom one-offs that are available, consider using a service like Rent-A-Coder or some similar service that posts all kinds of small and short-term software jobs. Some of them can be completed in as little as an hour. Some of them might be a month's worth of work. But if you're trying to kick off a micro ISV, it's a good idea to take stuff like this on so that you have some proof that you can do what you say that you're capable of. Each project you complete can become part of your portfolio, because you can run your mouth all day long, but if you have no proof, who cares? Social media obviously is the way that a lot of things get marketed these days, and that shouldn't be your only avenue to market your micro ISV. However, if you follow smart people on Facebook and get them to follow you, and you follow smart people on Twitter and get them to follow you, and so on, you will bump into somebody that will require your services or give you a really good idea of what you can do to make some money. And the best thing about social media, in my mind, is that it's free and so easy to do. And network, network, network. If you think you can get a micro ISV off the ground without getting out there and talking to people, whether they be in the software business or not, you're a little bit delusional. I would suggest joining as many local business related clubs, Lions Club, Kiwanis, community leader clubs, those type of things. People that do those things are well connected. Connections is what it's all about. Oh, and I forgot to mention, go to conferences when they're available. Join advisory boards and councils. And you can't be shy. You just can't. And it takes time to build trust. Don't get frustrated. Don't think that you're going to be a huge success overnight. It may take months or a couple of years. And it's a lot harder to get trust than it is to lose it. Once you've chosen a type of software to create and you've got a good idea, you're going to have to know about the software platforms and tools that are available that you can use to build your solution. So that's what we're going to move into now. And regardless of the platform that you develop on, there are some commonalities. So I thought I would start out with that. Keep in mind that each and every one of these platforms is going to require this knowledge. Rule number 1, good software always solves a problem. I don't care what programming language you use, what operating system it's using, what hardware that you're running it on. You have to solve a problem or it's not good software. There I am, coming back to that again. Your customers generally don't care as long as it works in their environment and their situation. Keep that in mind. I am not a snob toward any single technology if it can make me money, I will use it. The first thing that you need to know is database skills. Okay, databases help store information and retrieve it. Any program of any decent complexity is going to need to store and retrieve data. Okay, mobile apps, desktop apps, web apps, it doesn't matter. There has to be a way to store what gets put in, what gets processed, and what gets put out. Most databases use a language called structured query language for issuing commands. And regardless of the database, there are generally a lot of similarities between the syntax that's used with different databases, but almost all databases have certain commands that only work on that particular database. Mike knows a lot about Oracle. I know a lot about MySQL. I know a little bit about SQLite. He knows a little bit about Java Derby. We basically know about the databases that we use the most, and every once in a while I'll dig one out for some crazy purpose that I may not use a lot. But the point is, if you know one set of SQL, chances are you can pick up on the other ones pretty easily. And some databases are client-server based, which means that the database sits on a separate server, and the client, that might be a computer or a tablet or whatever, reaches out and pulls data out of that. And some of them are local databases where all of the information stays on somebody's hard drive or in somebody's phone, but you need to be aware that those are two different usage models for databases. Now let's talk about common databases and the platform that you see them on the most. Okay, for desktop apps, you've got Microsoft Access gets used a lot, and that's for Windows only. And then there's SQL Server Compact Edition, that's for Windows only, and also the new Windows RT for tablets can use SQL Server Compact Edition. There's FileMaker Pro and Bento. It's basically the same database, but FileMaker Pro is Windows, Bento is Mac. It's made by the same company, so any SQL or logic is common between the two of them. SQLite is everywhere. It's free and it's cross-platform, meaning that it will work on almost any operating system or environment that I can think of. It's used in some desktop apps, and you'll see here momentarily it is used in mobile apps as well. There's JavaDB, and if you're working with Java, which you're going to see Java itself all through this presentation because it is a language that can do so much on so many different platforms. But if you're going to be using Java, JavaDB is definitely a good option a lot of times. Generally, it's only used for local databases, but you could use it in the client-server configuration. It's just not common to see it used that way. Okay, for web apps, there's MySQL. That's the most widely used database on the internet, and the biggest reason is it's free and open source. Oracle is the second most used database, and Oracle actually owns MySQL now, but Oracle has been in the enterprise space for decades, and their database is probably the most robust in that it handles huge amounts of data very, very easily, but it's also quite expensive. Then you've got Microsoft SQL Server is the third most common database in use on the web. And obviously it's from Microsoft. If you're going to be doing anything with their tools, it is fantastic. It just ties right in real nice. That's the advantage of using one vendor for doing software. For mobile apps, you got SQLite, and I forgot to put JavaDB on here, but it's used as well. Take note that there are other databases besides the ones I've listed here, but these are the most common and the ones that you'll see the most of, and the ones that there are more resources online for learning about them. And also, make sure to follow these links if you're interested in learning more about each of these types of databases. Almost all applications, at least modern ones anyway, consist of three parts. There's the graphical user interface, the application logic, and the data. Now the GUI is what the user sees, and that's checkboxes, drop-down lists, text boxes, forms, and so on that they click on, they type in, and that's how they get information in or out of the machine. The application logic takes input from the forms or even, text to speech or whatever, and turns it into some useful output. In other words, it's the business end of the software. To go back to one of my previous examples, the database the guy developed that tracks driver point totals, somebody has to put in how many laps they led, what position they were in for the majority of the race, and so forth. And the application logic is what actually calculates point totals based on those inputs and then spits it out so that the user can see it. Data are the things that we created and we want to be saved for later use. Data is not static. That means that it can be changed. So all databases can create, read, update, and delete records. That's known as CRUD. So keep that in mind. Now let's get into desktop software. And this happens to be software that runs on laptop computers and desktop computers. It's a very old market. You don't hear much about it anymore. It's almost invisible. Market growth is pretty flat, but according to the Business Software Alliance, which is an organization that tracks software purchases by companies of all sizes, in 2011, $88 billion was spent on desktop software. So that's in industries like hospitals, banks, beauty salons, places like that don't necessarily have all of their information on the internet. Just because the media ignores desktop software and acts like it's irrelevant these days doesn't mean it's actually so. They just like to follow things like mobile that is the big hot topic because that's what people are fascinated with at this point. Desktop software is usually installed on a particular machine, and there's several common desktop software platforms. Microsoft Windows is by far the largest, with about 93% of the market. Apple OS X hovers right around 6% of the market, and Linux is right around 2% of the market at any given time. And it fluctuates, maybe a point here, a point there, but never forget that Windows is by far dominating the global software market for desktops. And like everything else we've talked about, each one of these has its own advantages and disadvantages. And remember rule number 1. Good software always solves a problem. The platform doesn't matter. And it's not easy to do well on any of these platforms, but I never said anything about easy. So let's talk about cross-platform desktop software first. And anytime we say cross-platform, that means it'll run on multiple environments. In this case, cross-platform software will run on any of these operating systems. And I say theoretically here on this slide because the write once, run anywhere mantra is nice, but even with cross-platform solutions, you usually have to do a little bit of tweaking between one operating system or another to make sure everything runs just right. That being said, it's a lot faster than developing natively for each platform than it is to just tweak a few times to get it to run on all operating systems or platforms. And it's absolutely great whenever you have a company that runs some Windows machines and runs some Macs and maybe has a Linux box or two sitting around. If you can write cross-platform software, you make the customer happy and you have to put in a lot less work because you write it once and deploy it numerous times. And remember, it's never 100% cross-platform, but it gets pretty close. And here we go with Java again. Java is the king of cross-platform desktop apps, and cross-platform web apps for that matter, and cross-platform mobile apps. And we'll see some exceptions to some of this. But the point is, Java is a good way to go if you want to go cross-platform. It's highly supported. A lot of people use it, and you just can't go wrong with learning Java. The latest reports that I've read from several sources say that Java will be relevant for at least 10 years, and that's an eternity in the software world. If you're going to develop Java, there's two integrated development environments, IDEs, that are good options. Eclipse is by far the market leader. About 80% of Java developers use Eclipse. NetBeans is the next closest one, and then there are some smaller ones. But the fact that Eclipse is so widely used makes it a good candidate to learn Java on. And there's more written about it, it's more talked about, you'll get more support from the community. And there's another really popular cross-platform language called C and C++, and C is the granddaddy of all cross-platform coding. Java borrows a lot of things from C and C++ and attempted to improve on a lot of things. Now, C and C++ is a lot harder to work with than Java, and it's harder to find people that are really good at it, but it is extremely powerful and extremely fast. And there are many good IDEs that can do C and C++. Eclipse and NetBeans, as a matter of fact, are very good C and C++ IDEs. But there's also Code Blocks and Embarcadero C++ Builder. They bought out a company called Borland, who was very popular with C and C++ coders. Code Blocks is free, Embarcadero products are not. Eclipse and NetBeans are free. I forgot to mention that, but it's very important. And here's what Eclipse and NetBeans look like. You can see they're quite similar. You can't go wrong with either one. Let's talk about developing on the Windows platform. And anytime I say developing specifically on a platform, it means that it will not run on the other platforms without either some kind of emulator or a great deal of work to get it to function properly. So when you develop on a particular platform, you just know that it'll work on that platform with no guarantees of anything else. And here we go with Windows has 92% of the market. I think I said 93% a moment ago, but 92% of the market. And there are a massive number of existing programs on the market for Windows. It's just because it's such a big honeypot. Anytime you have such a huge market sitting there, there's just going to be a mass number of people that flock to it and support it. It might be tough to find a niche that isn't already filled. I mean, let's take, for example, word processing, which is hardly a niche market. But if you were to try to put out a software product that took on Microsoft Word, or even Corel WordPerfect, those are the two commercial pieces of word processing software that still exist. If you try to take them on with a new product, you're going to have a hard time because there's just so many people already using the big dogs. And there are good communities for the Windows development platform. When I say community, I mean forums and places that post articles about how to do development on Windows. So they have a good community. The MSDN network is officially run by Microsoft, and you'll spend a lot of time there looking things up to figure out how to do stuff if you're developing on Windows. Then there's sites like Code Guru that are actually a good resource for all the other platforms as well. Dr. Dobbs' journal is also a very good resource for the other platforms. And if you're going to develop on the Windows platform, you're going to use either Visual Studio or Visual Studio Express. There are some other options, but these two are built by Microsoft and are tied to Windows very, very closely. So it makes development really easy. And the Express version, obviously, is a little stripped down, but as far as getting rolling and getting started with things, it's great. It's fine. You can make a lot of money with an Express version of Visual Studio. And one of the best things about Visual Studio is it does support a host of Microsoft specific programming languages: C++, C Sharp, Visual Basic, J Sharp, and it basically just depends on your personal preference. C++ is the fastest of these, but it is also the hardest, and you have to do more things manually. It's not as automated. C Sharp is Microsoft's own take on the way Java is built. It's not a ripoff of Java 100%, but one has to think that they probably looked at Java and said, that's a pretty good idea. Let's make that just for Windows. Visual Basic is a newer take on Microsoft's QBasic or QuickBasic, and J Sharp is kind of a experimental type language. And there are other development environments, like I was saying. You can follow that link there to get more information, but there are so few people that use anything but Visual Studio if you're developing Windows apps that I would suggest you steer away from the other environments if you want a wide range of support and something that a lot of other places are going to use as well. Monetizing Windows platform applications. And the monetization for desktop applications is pretty similar across all platforms. The best thing about the Windows platform is you can distribute apps online or on a disk. Distribution of software on a disk is slowly becoming less common. It's just because it's so much easier to have somebody download something than it is to get a disk, and if you're selling it at retail, have it sit on a shelf and maybe not even be purchased. You can do trial versions that expire after a certain period of time or that have limited features, and then people can pay to get the full-blown version. Freemium is a word you'll see a lot. It basically just means you give them a real stripped down version that's missing a couple of things that people really want, and then you try to upsell them the full-blown application. And you can sell direct with no trial, but that's just not a very good business practice because people need to try it out on their computer or in their environment to see if it's going to work for them. And if you don't let them try it out on their machines, it's kind of a toss-up, and most people won't take a chance on spending a chunk of money on a expensive application that they can't try out first. Windows 8 has been out since October. It has the Microsoft Windows Store that can be used to distribute full screen apps, but it's really an early market, and most apps in the Windows Store are free. We really don't know at this point how profitable it's going to be. Now, here's the catch-22 of the situation. If it ends up being a profitable market and you don't jump on the bandwagon early, you might miss out on a chunk of change. However, if it ends up being a major flop and you spend all this time creating a Windows 8 app, then you're out a bunch of money, a bunch of time, and just being aggravated, I suppose. You can embed advertising in desktop applications. I have a couple of things installed on my machine that show advertising whenever I use them, and it works pretty much like it does with a web app. It goes out to the internet and pulls in an advertisement. There are a couple of pretty big name companies that do this, Influ-Ads and Buy-Sell Ads, but the thing is, most of the companies that provide advertising inside of software aren't really that interested in desktop apps because that's not where the money is. Like I said, mobile and web is what the media goes on about, what the news coverage is, and what people are flocking to, and we'll get into that momentarily as well. So you're kind of limited with your options of how to display ads in a Windows or any desktop app for that matter. And advertisers are more interested in mobile apps. OS 10 development, and OS 10 has 7% of the market, and I really screwed those percentages up a while ago, but it's been pretty steady at 7% for a while. But here's the thing that's interesting. One study found that Mac users have more money to spend, and that comes in really handy to know whenever we start talking about mobile. You may actually have a better chance of getting a Mac user to pay for a piece of software than you do a Windows user. I mean, it's not 100%, but that's what the numbers suggest at this point. One of the big disadvantages of OS 10 development is it requires a Mac computer with OS 10 installed. Now, all Macs come with OS 10. The reason I say for legal development, it is possible to run OS 10 on a non-Mac computer, but it's also illegal. If you're developing software on an illegal device, that would make your software illegal by association. So the reason that it is a bad thing that you have to have a Mac is that Apple hardware is a lot more expensive than equivalent Windows hardware. To some people, that doesn't matter. They use Macs anyway, and that's fine. But if you're looking to break into the market and you're not really a Mac user already, just know that you're going to be spending more money up front to shoot at a much smaller pie. That may be richer or sweeter, if you will, but that's up for you to decide. There's not nearly as much competition as Windows, okay? Whereas on Windows, there might be 10 programs that do something. On OS 10, there may only be one. But the existing solutions for OS 10 are often highly polished. And they look good, they work well on the Mac, and there's just something about the quality of existing OS 10 apps that makes it really hard to break through as the new kid on the block. Now, your niche markets on OS 10 are a really good avenue to go if you want to get into OS 10 development, because niche markets are small anyway, and since OS 10 has a small share, there's probably some niches out there that does not have an OS 10 component that may have existed on Windows for a long time. You monetize OS 10 apps pretty much like you do Windows apps. They can be distributed or sold via downloads or sold on disks just like Windows. You can do the trial versions, freemium, sell direct, no download. Like I said before, don't do that. Apple has the OS 10 App Store, which if you have the two latest versions of their operating system, then you have the ability to use this App Store. And it's basically very, very small compared to the iOS App Store in terms of size and monetization. Okay, Apple improves all apps that end up in the OS X App Store and can pull them at any time for whatever reason it deems necessary. This is somewhat controversial, and it's an added risk if you're going to distribute a piece of software through the App Store. Some people are fine with it, others are not. And currently, there's no way to sell apps at upgrade pricing any different than you would the first time they buy it. So that's kind of a big turnoff because a lot of software allows you to upgrade cheaper than it is to buy it the first time around. And the App Store at this point doesn't allow that. Now, that could change at any time because the App Store and things like that are very fluid in this market. You can do embedded paid ads, but it's the same as for Windows. Uh, they're just not that interested in it. And when I say they, I mean the advertisers are not that interested in it. That's not where the big money is. Now, Linux, for people who may not know, is a free operating system. It's been free since the day it was created, and a lot of really technical people use it for technical reasons, and some people use it for philosophical reasons because it's free. It has a relatively small market share, but it is a bigger market share than it had in the past. It's right around 2%. And it's known as fragmented because there's not one type of Linux per se. There's a lot of different types of Linux. And that can be an issue for some people. The installation routines on each of the distributions is not always the same. And the popular ones are Ubuntu, Linux Mint, Puppy Linux, SUSE Linux, but there are literally hundreds of different distributions besides the ones I've listed here, and it's just a real pain to support all the different ways of installing software. And here's one of the big caveats. Because Linux is open source, most of its users think that any software you would put on it should be free. So that's kind of just a way that you may or may not make money trying to sell the software itself. Now, there is an option that works really well on Linux, and that is you sell the support for the software. Give the software away if a company wants premium support so that their technical people don't have to dig around on forums, or if they want to be able to just pick up the phone and call, they can pay for the support if they need it. If they don't need it, everything's totally free. And the article I've linked to there provides numbers that suggest that selling support is profitable and that Linux users are okay with this. Now, let's get into mobile app development, which is an absolutely huge space. The article I've linked to there provides you with a clue of how huge and fast growing this market is. By 2015, which is just right around the corner, it's expected to be a $25 billion market. Now, remember I said that in 2011, desktop software was raking in $88 billion. So, desktop software is still the king. But mobile app development is growing very quickly and will just continue to get bigger. There are several platforms, which is both a blessing and a curse, because that means if you're wanting to support more than one platform, you have to do a bunch of stuff to make it work on the platforms, but it also leaves room for competition in case there are competitors that are only focusing on one platform. You can just use a different platform and create the same solution. There's iOS, which is what runs on iPhones, iPods, and iPads. There's Android. There's BlackBerry, which we know they've had a lot of trouble in the last 5 years. The iPhone and Android have really just chipped away, but they were the first smartphone maker. They're still really popular in the enterprise space. Big corporations still issue them to their employees because BlackBerry is built around the way that enterprises need to work with security and authentication and things like that. And then there's Windows Phone. Microsoft's trying to make inroads, but thus far it's had sort of a lukewarm reception. We'll talk more about that in a little bit. And like I said, developing the same app for multiple platforms takes time. And there are ways to develop once and deploy on many platforms, but it's just another platform to learn in and of itself. There's a real popular one called Corona SDK, and it costs money. I'm not incredibly sure how much because there's some restrictions to it, but I know that it's a few $100s. And then there's an open source one called MOI that does the same thing as Corona, but from what I read, it's kind of buggy and it's just one more thing you got to worry about. So if somebody figures out how to do cross-platform development easily, they could be raking in the money. So this is quite interesting. Your mobile app market share. Okay, Android has 52% of the market. Now you're looking at that and you're thinking, why doesn't everybody develop on Android? We'll talk about that here in a second. Then iOS has 39% of the market. BlackBerry has 5% of the market, and Windows Phone has a measly 3% of the market. And this came from ComScore and was published in March of 2013. That's no surprise there. We already established Android's bigger, but iOS apps make more money. And if you follow that link there, you will see that iOS developers get more money by far on average than Android developers. Now here's another thing you really need to keep in mind with app stores. Okay, even though the App Store has a lot of apps on it, the vast majority do not make that much money. Okay, the median earnings for paid iOS apps as of 2011 was $682 a year. Median is the middle. That means that 50% of all the apps on the App Store make less than $682 a year. And the ones above that make more. Now the average, okay, not the middle, but the overall average money made on the iOS App Store was about $4,500. So what this means is that there are some apps at the top of the heap that are raking in the money, but most of the apps do not do so well, even though there's so many. Remember rule number 1, the apps that rise to the top solve a problem for the customer, and apparently solves it for a lot of people. Okay, and apps don't really cost that much. That's another thing you have to think of. You're not going to be raking in a ton of money off of each app. Now, if you're going to get into developing on each of the platforms, here is the development environment as well as other things that you need to know about that platform. So, if you want to take a stab at the best paying of all the platforms and be an iOS developer, you're going to need Xcode, which is free with any Mac. There is a $100 per year SDK fee. When you sell apps, 30% of the revenue from paid apps goes directly to Apple. That's their cut. And you'll see that everybody else is doing this too, except Microsoft is trying to differentiate and be clever. We'll get to that. But one of the things about Apple is they have a really closed off approval process. Okay, they have a bunch of reasons that they'll deny an app. If they deem the app as being tasteless or offensive, or if they deem that you're using a photo that shows too much skin, as in a lady in a bathing suit, then your app can be pulled. Okay, and I've provided links to some pretty big name apps that got rejected a lot of times. The Guardian in the United Kingdom, huge newspaper, had its app rejected, and the New York Times got rejected for some reasons. So it's kind of a toss up, and there's nothing you can do if Apple chooses to reject your app. Now, Android runs on all kinds of phones and tablets, and the reason it has such a huge market share is you can install it on so many devices, and Google owns Android. They don't charge anything for it, and so it's really a booming market in China. If you're going to develop for Android, you're going to need Eclipse with the Android SDK, which is built in Java. So there's Java again, all over the place. Okay, there's a one-time fee of $25 to sell paid apps. After that, Android gets 30% of the revenue. Now, unless you're installing malware or something that is explicitly made to mess up people's phones or steal their information, the Android Google Play Store will not reject your app. Their approval process is very easy. So you don't have to worry about them pulling your app like Apple would. Okay, now some people see that as a bad thing because your app is going to be tossed in with a cesspool of bad apps or apps that aren't that great. But hey, there's always a trade-off with freedom. Now we have BlackBerry, 5% of the market. If you're going to develop on BlackBerry, you're going to need the BlackBerry SDK, which is written in Java. There we go. There's no upfront fee for selling on the BlackBerry World Store, but BlackBerry gets 30% of the revenue. Okay, so Apple basically set the stage and set that percentage price, and everybody else is following except Microsoft with its Windows Phone offering. And you're going to use Visual Studio for Windows Phone, and that gives you a choice of C Sharp or Visual Basic or Visual C++. There's a $99 annual development center fee, and right now it's on sale for I think $25, but that's only for a limited time. Microsoft gets 30% of the revenue on your paid apps for the first $25,000 in sales, and that would be great if you were one of the lucky ones that had an app successful enough to get that. But then after the first 25,000, they drop the percentage and only take 20%. So if you're planning on hitting a home run, you're going to make more money with Windows Phone, but with 3% of the market, it's kind of a small target to shoot for. Monetizing mobile apps is the big thing, and a lot of apps make a lot of money through advertising that has nothing to do with selling the app itself. But you can sell the apps just like anything else. A lot of apps are 99 cents. You'll see some for $2 or $3. Occasionally you'll see some really important enterprise piece of software or some educational software that might be $100 or a couple $100. One thing that you can do, and this is basically the same as on the desktop, is create a light version or a free version that has limited features to hook your users. For example, when I had a BlackBerry, there was an address book that was really good that had a light version, and the paid version would go through and find duplicate contacts and either combine them or delete them, and it was really good at doing that. I actually paid for it because that was just something that I really needed, and I really liked the light version of the app anyway. You can display ads in free mobile apps, and a lot of companies are making money doing this. AdMob is huge, and Google bought them a while back. You've got OpenX, which is also huge, And these companies wouldn't be getting so big if the mobile ads didn't work, as in didn't attract eyeballs, because that's what advertising's all about. There's Appia and the Amazon ad network. It's really hard to find any good data on how big each of these mobile app ad companies are, because they're all in fierce competition at this point and keep everything close to the vest. But it apparently does make money, and the ads must be effective for the companies buying them, because you wouldn't be seeing this level of growth if it wasn't successful. In-app purchases is by far the way to make money in games. Okay, now there's other types of mobile apps that will allow you to make money with in-app purchases, but with games, that's just a huge way to make money. Okay, basically what that means is, say you're playing a game and there's some kind of currency in game. Okay, you can actually spend 99 cents and get a ton of that currency to use in game to buy a better sword or a better pair of shoes that let your little character jump higher. They might sell you another level of some game for 99 cents, but it all happens inside the app. In other words, you give the game away for free, let the user have a limited set of features, or make it really hard for them to get the good features, and then you sell them something that makes the game more fun or easier. People will do that. It's a huge market. If you look at some of those articles I linked to earlier, you'll see that there's more money made with in-app purchases than there is in selling apps outright. Now, let's talk about web development. And web development is awesome because it's cross-platform by its very nature. Okay, as long as the device that you're trying to support has a web browser that supports a minimum version of certain web programming protocols, which we'll talk about in a minute, you're good to go. So web development actually is sitting right up there with mobile development as being important, because you can develop apps that work in a mobile web browser, on a desktop, on a TV, on a billboard. There's just no limit. It all runs in a web browser. Web browsers have been made to run on anything and everything these days. And there's this concept called responsive design that's a lot easier than developing a cross-platform mobile application, where you basically have the same structures of your web pages, but there's special instructions that tell it, okay, if the screen is this big, just make it look this way. If the screen is that big, make it look another way. That's not 100% easy to do, but it's a heck of a lot easier than trying to be cross-platform in other ways. Your content remains the same with responsive design. Only the looks of the thing changes to fit your environments. It is more work for the developers, but if you do responsive design properly, the user never even notices they're being served a custom look for a specific device. The thing about web development is, if you're going to get into that, it does rely on many, many technologies. And all of them kind of work together, but each one of them is separate in its own way. And we'll get into kind of how that works momentarily. It's a tiered architecture, which basically means there's different pieces. And we'll talk more about that as we go along. But I just want you to know, if you're going to have to learn 3 technologies, for example, for a mobile app, there's going to be 5, 6, or 7 that you're going to have to learn for a web app, depending on what you're trying to do. Okay, there is the data tier, which is your database. And remember, that's on all platforms, so no surprise there. There's the data access tier, And that's the programming language or technology that you're going to have to deal with, or technologies, I should say. There's many more than one. Then there's the business logic tier, and that's where the stuff is pulled out of the database and then stuff happens to it depending on what you're trying to do. Then there's the presentation tier, which all runs inside of the browser once the server gives the processed data back to the browser that requested it. And here's where a bunch of the technologies that I'm talking about come into play. HTML, CSS, Flash, JavaScript, and there's even others. So we'll get into that also. Okay, then you've got the GUI itself, and that's you have to worry about the different web browsers. They're fairly cross-platform, but there's just certain little caveats you have to watch out for. So while web development is awesome, it can be a little more scary than some of the other types because of so many technologies interacting in so many different browsers. There's a bunch of web development tools. The first thing you're going to need is some operating system that can run a web server, and that can be Windows Server or Linux or OS X. Any of that can run a web server. Then you're going to need a web server itself, and there's lots of web servers. Apache is the most popular on the internet. It's estimated that 70% of all websites on the internet run Apache. And the reason I say estimated is depending on what source you look at, you're going to see some different numbers. But 70% seems like a happy medium between all of the things that I've read, and it does seem to be everywhere. And then there's a thing called Lottie. It's kind of a newer player, but it will run on older equipment, so you don't even need a very fast machine to use Lottie. Nginx is very new. It's been around since about 2006, 2007. It's really fast and will run on almost anything. Then you've got Microsoft IIS, and if you're going to be using Microsoft development tools for websites and so forth, it's the way to go. A lot of huge industries use IIS. It's a very mature product and works very well. And it runs on what's known as .NET, which is what C# and C++ and all of that is built on top of as well. There's Cherry Pie, which if you're going to use Python as your language, Cherry Pie is a good web server. It's used by a lot of people that do Python. Then there's Tomcat. Here's Java again. Tomcat runs a special type of Java and was written in Java. So if you're a Java person, that might be a way to go. Then you're going to need your database, and I basically just linked back to the slide about web databases. We talked about all those, and the cool thing about the databases are generally you can get any of the web databases that we talked about, MySQL, Oracle, Microsoft SQL Server, any of that, you can get it working with the web server listed above. Now, following the database, you're going to need some web programming language. Okay, and there's so many options here, and now once you have a database and a web server and an operating system in place, it's time to start worrying about your programming language. You have so many options. There's two main types of programming languages. There's a scripting language, which does not have to be processed before it can be used, and then we'll get into compiled languages shortly that have to have some processing done to them before they can be used. The scripting languages usually let you develop a lot faster. In other words, get something working. However, they run everything somewhat slower. whereas the compiled languages take a little more work to get running, but once you do, they run things faster. That's a whole philosophical debate as to which one is best, quote unquote, that this presentation will not and cannot really solve, so I'm not even going to get into it. I just want my audience to realize you have options. That's what this whole presentation has been about. There's so many options. PHP is a very common scripting language. It'll run on any of the servers listed to the left, with the exception of Cherry Pie and Tomcat, because those are geared toward those languages specifically. You can develop very, very quickly in it. It's really, really easy to learn. It's got some issues, but it's incredibly popular. The software package that runs 70% of the websites on the internet is called WordPress, and it is written in PHP. So you can see from the adoption of a package that's used by so many websites that PHP has plenty of use and is good enough to do what it does. Then you've got Python, and what makes Python so awesome, you can actually use it to write code beyond web development. You can even do desktop applications in it, but I didn't include it in the cross-platform desktop app slide because scripting languages are usually not used for sellable software. But Python has a vast number of functions built into it that make certain things really simple. It's such a good language, in fact, that at most universities, it's one of the first languages that computer science students get their hands on. And it also happens to be pretty good for doing web pages. The majority of the companies that Google buys that have some kind of web business use Python. So Google, in and of itself, likes Python. And if it's good enough for Google, it's good enough for most of us, more than likely. Ruby on Rails is another extremely popular web programming language. It allows you to get websites and pages and applications up really, really fast, and it has some faculties built into it that make it really easy for the programmer to tie the application logic to the database. It's probably better at that than any of these others. Ruby, as it's often just called, is what is used to make Twitter, and we all know how big and popular and lucrative Twitter has been. Then you got Perl, which is really, really old school, but it's still used occasionally. If you want to get into a niche market, Perl might be a good way to go. It's not really that popular, but somebody's still got to do it. And you could even do it with something built into most of these servers called server-side includes, which is very old school. I wouldn't recommend it, but I just want you to know, where there's a will to make a web application, there is a way. Now we've got the compiled languages, and there aren't as many of those. And like I said, they run the web applications a little bit faster, or sometimes quite a bit faster. However, it takes longer to actually get the web app up and going with them. You got Java, which uses a technology called JSP, and you have .NET, which is, like I said, C++, Visual Basic, and C#, and it uses ASP.NET. All of these languages, both scripting and compiled, have lots of support online, lots of books written about them, and just a lot of buzz. In other words, you will be able to find information about them if you're having trouble. Now, once you get all these pieces working, you have to worry about your markup and presentation languages. And this is the stuff that runs in the browser that makes stuff happen. You have HTML4 and 5. Okay, HTML4 is an older version. HTML5 is the new hot topic. And it actually will allow you to do some database stuff in the browser, which is kind of a new thing. It's, not really been around that long. HTML4 has been around since 1999. But anytime you have structure in a web page, you're going to use HTML4. Now, what am I talking about? Well, it's like in this PowerPoint, we have a title at the top of each slide, and then you've got these bullet points. So HTML basically does the same thing in a web page. It allows you to specify what information on the page is a title or a subtitle, what information is part of just regular text, what information is a bulleted list, and what information is a paragraph, and so on. So that's your structure. Then you've got CSS, which controls appearance. And for example, in this PowerPoint, all the headers are red, everything else is gray. You've got the links that are kind of orange. Well, CSS on a web page does the same thing. You can change colors, alignments, backgrounds, font size, font color, and so on using CSS. Stands for Cascading Style Sheet. HTML stands for Hypertext Markup Language. Okay, these two things work together. HTML lays out the structure. CSS makes it all look pretty. Then you've got JavaScript, which is your browser-based interactivity. Let's say you go to a web page and a little box flies out over top of the page that says, would you like to take a survey? You have to click a button to make it go away. That was probably done in JavaScript. And JavaScript allows things to happen based on what people do inside of their browsers. And without JavaScript, the web would be fairly boring. So there are your three pieces of the markup and presentation languages that you have to know. So from looking at this one slide, I hope you understand my point a while ago about it being a multiple technology showdown. You've got an operating system. On top of that sits a web server. Then you've got a database that sits on top of some operating system. Then you've got a programming language that ties the web server and the database together and also does processing of its own. And then you have the presentation elements that actually get the information out to the user of the web application. So web development requires a lot of different tools in order to do successfully. Now we have a nice little graphic that depicts the same thing. And you'll see that it's all based on requests and responses. Okay, so this is a very simplified version. The web server kind of sits in the middle of everything. The user makes requests, and then the web server takes it and passes that off to the programming language. The programming language can connect to the database, pull stuff out, do some stuff, and then spit it back out to the web browser. And this all happens really fast, and anytime you visit any web page of any complexity, this happens a lot. Just bam, bam, bam. Okay, and you can see we've got it divided into the front end, which is the stuff the user sees, the structure, the looks, and the interactivity in the browser. Then you've got the back end where all the processing and pulling stuff out of the database, and deleting stuff out of the database, reading stuff out of the database, and so on happens. And this is called the back end. It consists of your web server, programming language, and the database. And the beautiful thing about the web is most users only care about what they see here. What do they put in? What do they get out? You are free to do it back here however works for you. And that's the whole point of this, is for you to understand what kind of options you actually have when you're doing some kind of development. Okay, you have to be willing to learn these multiple pieces. If you're not willing to learn that much new stuff, you probably should stay away from web development. There's usually 10 different ways to accomplish the same thing. Basically depends on what makes you happy, what your attitude is, and so on. Now, since there's so many things to learn, this is what I would suggest. You should start learning HTML and CSS first. The front end, the stuff that shows up in the browser. Because the web started out without any of the database stuff and the programming languages and all that. web pages used to just display information. It is possible to make web pages that do nothing but display information and then put some advertising on it and make money doing that. We'll see more about that later. But you wouldn't necessarily even have to fool with programming languages and all that. But you do have to be able to show the user something. So I would start with that because that's what most of us did. Get some simple, goofy little web page working in a browser on your local computer. You don't even have to have a web server. But you are in the process of learning these things, and these are called markup languages. They're not true programming languages per se, but they do have syntax, which is formal rules, and it will get you used to thinking in terms of syntax and rules and all that type of thing, because computers are inherently stupid. You have to learn to follow their rules. It doesn't work the other way around. Like I said a second ago, you can't have a web application without showing stuff to users. Then, once you figure out the HTML and CSS, set yourself up a web server locally. It doesn't have to be out on the internet. The only person that'll be able to access the thing is you on your computer, but it will serve a web page out exactly the same way as if you were sending it around the globe. And if you can get your web server up and running and can actually have that web server spitting the page out to the browser with the browser thinking it's connected halfway around the world, you're good to go. Then, once you've figured out these two pieces, move on to the programming language of your choice. Okay? Just pick one that you're interested in and go with it. And if you decide you don't like one, go get something else. All of these programming languages are free, so you don't have any excuse. And after you get your programming language figured out, make a database connection with that programming language. And a database is exactly like a web server in that you can install the thing locally. It doesn't have to be out on a web server halfway around the world. You can install it locally and interact with it just like it was sitting in China, for example. So once you figure out how to make a database connection with the programming language of your choice, all of the basic pieces are in place because you can show stuff to the user, you can send stuff to and from a web server, you can process stuff that's sent to and from a web server in your programming language of choice, and then you can have storage to store and retrieve data that is stored in the database. So this is how those multiple technologies work together. And the fact that you have so many options is great, but I also understand that it may give you anxiety because there's not one clear path to being a web developer, and that's okay. So let's talk about monetizing web applications. You can display ads and pages, and there's a lot of money to be made doing this. Google gets the vast majority of its income, about 90% of it, from ads. And we all know Google isn't hurting. It's called Google AdSense. Basically, you put ads on your web page, and then when people click on it, you get paid. Okay, and then the flip side of that, businesses pay Google to display ads on other people's pages. So Google's kind of the broker that both buys the ads and sells the ads. They sell the ads to the businesses wanting to advertise. They buy the advertising space from the what's known as the publisher that puts the ads on the page. So and everybody else does the same thing. You have Amazon. They do really well. With them, you can actually go to a specific product, get a little advertisement for it, and stick it over on the side of the page. So let's say you've got a web page about fishing. You could actually link to a certain fishing pole. If somebody clicks on that ad that you have on your page, goes to Amazon and buys that pole, you get a percentage of the sale. Then you've got Yahoo ads. They've been at it a long time also. but all three of these companies basically do the same thing. They do pretty well at it. You can do direct advertising deals, and that might work with local markets. Say you wanted to sell an advertisement for a local gas station on a forum that you have for people within your community. That might be a good idea, but that's generally really time intensive, and most micro ISVs don't have the resources to do direct advertising deals. You could sell subscriptions, and that works for news outlets and things like that. Also, you've got these places now that sell training. So you could put up a website that has videos, kind of like this one, and that show people how to do something, and then sell subscriptions so that they pay so much a month or year and get to access your content. Now, in order for this to be successful, you have to keep updating stuff as time goes along. There's also another kind of subscription called software as a service. It's a fast growing market. Microsoft and Google are both heavily engaged in it. That's where you sell software that runs entirely in a browser, and it's subscription based. Whenever the customer is done with that software, they just stop paying the subscription fee and they're good to go. Okay, so for example, you have uh, Office 365 that everything runs in the cloud, and you'll hear a lot about the cloud, but basically all that is a fancy web server that has a lot of stuff hooked into it, and everything is stored on these servers and is passed back and forth between browser and server. So I'm not going to talk about the cloud explicitly, but you will hear it. But software as a service is a growing market. You're looking at a $22.1 billion market by 2015. So, especially if you find a niche market that has clients that may be comfortable using a web browser for a certain process, that very well might be a way to go. Software as a service, and you'll see that abbreviated SaaS a lot of times. And like I already said, you could sell premium content, kind of like the New York Times and the Wall Street Journal. They give some of their articles away for free, but you have to be a subscriber to get the premium stuff. You can also do in-app purchases on web pages, and it works the same as mobile apps. Okay, you've also got things like Farmville and games, on Facebook that people pay for, premium corn crops or whatever. Now, let's move into learning to be a developer. And learning to be a developer is not really that hard if you're willing to keep trying until you get something to work. At first, being any kind of developer is kind of scary because you know what you need to do, but you probably won't know exactly how to do it. So, here is my advice to you. The internet is by far your best friend. Okay? Developers my age, and at the time of this recording, I'm 31, at my age and younger, have had a huge advantage that older developers didn't have. We had the internet. Anything you want to find out, there's stuff about it online. Now, granted, 60 or 70% of the stuff online is probably crap, but even the crap can give you a good idea of how to get started doing something the right way. I can't possibly answer all your questions about how to be a developer or what language to use or anything like that with this presentation. If I did 100 presentations, I couldn't provide you with that many answers. However, the internet can go as deep as you want to go, and most of this developer stuff that we've talked about lives on the internet. Even the desktop applications, you look up all of your resources and things about the programming languages online. So Google or Yahoo or Bing or whatever search engine you want to use is going to be able to hook you up with what you want. Now, I would suggest going to Google first because I've made a lot of money by finding a solution to some issue I was having on the Google, as some people have been known to say. And think about these questions here. To ask what is or what are the best, and then all of these different questions, problems to be discovered, problem to be solved, way to solve a problem, operating system to use, platform to use, programming style to use, development tools, ways to make money, ways to get people to buy my stuff. There are so many accounts of all of this out there on the internet. Chances are somebody will have answered your question, or at least you'll have multiple answers to choose from and figure out for yourself which one's best for your situation. And if you can come up with something that has totally been unanswered on the internet, you're probably going to be very, very wealthy. Which I hope that my audience watching this does become wealthy by becoming a micro ISV and turning into a ginormous enterprise. That would be awesome. So, since so much of your learning can be done online for free, it's important to know how to search for this stuff. Okay, so you could type the name of the language with the word hello world after it, and that is probably going to be the best way for you to find out how to get started with a certain language. You could do, say, PHP hello world in Google, or Python hello world in Google, ASP C# hello world in Google. That will take you to a page that will most likely give you instructions on how to install the stuff you need to make the language work and everything. It'll be kind of a one-stop shop to get you started. Hello world is simply a phrase that's used and has been used for decades to denote the first time a programming language actually spits something out to the screen, which is the standard de facto thing for, hey, it works at least a little bit. Also, you can type the name of the language or technology you want to learn about, followed by the word tutorial or sample, and you'll get all kinds of pages that walk you through setting up your development environment or walk you through kind of what you need to know. Now, like I said, 60 or 70% of what's going to pop up is probably going to be crap, but the other 30% will be gold, and even some of the crappy stuff will kind of show you ways to get started on something even if it isn't the best. Don't worry about doing it the best way the first time. Whenever you're learning this stuff, the best thing is to just get it to work at all. And once you get it to work one way, then you can worry about doing it the best way. And Rome wasn't built in a day, and neither are your programming skills going to be. You're going to have to start very, very small if you want to get into software development. Here's some stuff that every programmer I know worth his salt, or her salt, has tried to build or actually succeeded in building in whatever language or technology that you want to do it in. Is the very first thing is a calculator program, and that'll teach you how to add stuff together, subtract stuff, multiply, divide, and so on. And you can build the graphical user interface that looks like a calculator with your little operator symbols and your numbers, and then the user can click or type in a box or whatever, click a button or hit tab, hit enter or whatever, and it'll spit out the answer to your simple calculator input. Address books are another very popular thing that people build when they're first learning the language. You can do that in a web browser, and see, that would require you to use the web server, the database, the programming language of your choice, and anything else that might need to be in there in order to put in addresses and pull them back out. A posting system such as a blog, where you go type in a title of an article, type in some text, and then whenever you click post, it shows it in a web page with the author's name and the date that it was posted and the time. Okay, inventory trackers are a good thing to write to learn how to do certain things because, for one thing, it will require you to set up a database and have some pretty common business logic in there, like whenever something is sold, the inventory goes down. Whenever something is purchased, the inventory is going to go back up. And finally, another one that everyone I know has written in at least a dozen languages is a Fahrenheit to Celsius converter, or you could do, pounds to kilograms, whatever floats your boat. But you need to start writing these small programs in order to build some skills. Okay, and you're going to do a lot of things the wrong way at first, but as long as it works, that's a good thing. And with all of these things, you will learn the syntax rules and the logic, as in the order to string the rules in, on the platform that you're trying to master, whether it be a web language, a desktop language, it doesn't really matter. It's all the same difference. Once you get really good with one of these technologies, it's a lot easier to translate that into working with another technology. The first one is always the hardest. Okay, and practice, practice, practice. If you don't want to write programs just for fun or just because you can, you probably shouldn't be a developer. I have known a few in my life that they go to work, they write their little programs, then they go home, and they don't ever think about a program or a computer again while they're at home. Those people are usually miserable developers, or they're not that good at what they do. Now, if you sit around and dream about, I wonder if I could program a robot, then you probably have the mentality to be a developer. Never underestimate the power of a good book. The internet is awesome for finding, resources about whatever technology or language that you're looking for at the time. However, a good book written by a reputable author can be awesome for showing you the best way, or at least a good way, to do something. Okay, even after you've mastered a topic, it's usually a good idea to keep the book around for some kind of reference, because there's usually some part of a programming language that you don't use very often, and those parts are the ones that you may have trouble remembering. Okay, before you buy a book, read the online reviews for the book. Amazon, Barnes & Noble both have these. You can also find independent reviews, but I just like to read the reviews from wherever I'm going to buy the thing from. And if most people give it, 4 or 5 stars, then it's probably going to be of some use to you. There will be some turds, but some of them are really priceless. You got Amazon and Barnes & Noble, and the beautiful thing about Barnes & Noble, even though they have trouble, seems like, making money with this, you can actually go in their store and flip through their computer technology and computer programming section. They even have books on ISVs and micro-ISVs. I've never been kicked out of there because I sat down with a book and read through it without buying it. So, okay, now here is a list of notable series and publishers that I would recommend for anyone to look at these sources first if you're interested in purchasing books. O'Reilly Publishing, I would have to say, has taught me so many things over the years on a variety of computer related topics. And they actually have different series. They've got the Learning and Beginning series. If the book has the word learning or beginning in front of the title, it's meant for people generally that don't have a lot of programming experience. So you get an O'Reilly book with learning or beginning, and you're good to go. Now, Head First is kind of like the learning series, but I think that it throws you off on the deep end a little faster. And if you're really wanting to get down and dirty and start cranking out something halfway useful, the Head First series is great. And then they have the cookbooks, which are good once you really know what you're doing, and you basically just want to see a good sample of how to do something that you can actually just kind of copy and paste from. So O'Reilly is by far the one I would suggest over these others if they have a good book available on the topic. Also, you've got Rock's Press. They're really, really good. They have a series called Programmer to Programmer, which is for experienced developers. But they also have the Learning and Beginner series, kind of like O'Reilly. I think their Microsoft based books are better than O'Reilly's if you're into the Microsoft technologies, but that's just my opinion. Then you've got the Dummies books by Wiley Publishing. And what I've linked to here is basically their programming language section. Um, as stupid as the name sounds, some of their books are really good. Not all of them, but some of them. And like I said, every book from all these publishers aren't perfect, but the vast majority of them are a good starting point, and they will not do too much harm to you. And over time, you learn what to pay attention to and what to ignore. But I've bought a few really bad books in my day, but the older I get, the more I know, the fewer crappy books I end up buying. And let's not forget the value of formal education. It can be very helpful. I found my time at university very useful in helping me be a better developer and programmer. Credentials of any kind are good, college degrees or language certifications. There's a Java language certification, PHP language certification. Microsoft has a whole slew of language certifications and operating system certifications. Any of that stuff is good. And you'll actually learn skills that you need. Now, everything you learn in a formal education program will not be 100% useful to you, but you never know what some little skill that you're going to pick up is going to be exactly what you needed. Then you've got, basically two kinds of degree programs if you're going to get into being a developer. One is computer science, and it's a lot more math and science, and it's focused on what I like to call the middle. If you really want to understand the nitty gritty of how this stuff works, computer science is definitely the way to go. The other option is information systems, which is what I majored in. It's more business focused and focused on how to use computers and technology to help companies maximize the money they make. Now, I've worked on projects with people with computer science backgrounds, with information systems backgrounds, and with people with no formal education in programming. And I've seen really good developers with all of that and really good developers without all of that. So, and then I've seen really bad ones with all of this and really bad ones without all of this. So it pretty much depends on the person's mentality and how much they strive to be a good developer. And this formal education business is not the end of the road at all. It's only the beginning. Once you finish your formal education, you've still got a lot of things to learn. And remember, we talked about a little bit earlier, if you're not inclined to sit down and write any kind of program just for fun, you probably should stay away from having any kind of programming business, even if it's a micro-ISV. And remember rule number 1. Okay, good software always solves a problem. That should be your ultimate goal. Figure out some problem and solve it using software. Make sure you're having fun and don't give up. If learning these technologies makes you sick to your stomach, you should probably not do it. I keep saying that, but I know so many people that think computers and software and all that is for them, and then they end up miserable when they decide, hey, I don't like this. But rejoice in your small triumphs, okay? In other words, basically, if you can get two numbers to add up and be spit out on the screen properly, be happy about that. Every time you learn something new, make sure that you're You step back and think, hey, I got it to work, and 99% of the people on the planet don't know how this works. Another thing to make sure to do is challenge yourself to solve a problem a different way. Once you figure out one solution, you can feel satisfied and be happy with that, but always keep in mind that the more ways you learn to do it, that generally means the more ways that you've mastered your technology that you're striving toward. Try to do it either faster or with less code. If you can make it run faster, that's always helpful, even in, quote unquote, the real world. Doing it in less code is just a sign of efficiency and sometimes clever thinking. When you're learning to be a coder, you will fail. Sometimes you'll fail a lot before you succeed. Who cares? It's going to happen. Okay? And you won't always know how to do what needs done to solve problems that need to be solved. Okay, I don't know how many times I've been given a task, and the first thing that goes through my mind is, what? And then you think about it, and then you think about what you've done in the past and what you know how to do, and start stringing it together. It's like building Legos. And if you don't know how to solve the problem at first, big deal. Most programmers don't if it's an interesting problem or a new problem. Okay, and then just keep trying. And I've cranked out plenty of solutions in my life that weren't the best solution, and I knew they weren't the best solution, but they worked, and I got it done on time. And the client was happy because it solved their problem. Remember rule number 1. Over time, you develop a mental toolbox to fall back on. Every problem you solve builds your knowledge and skills that will help you solve problems further down the road. And like I said, if coding makes you overly nervous, bored, sick to your stomach, whatever, don't do it. Find something else to do. It may not be your calling. You could still work in a micro-ISV. You don't have to be a coder. There is a need for business and support people floating around. But I think it's important to know if you like it or if you don't. And thank you so much for listening. I hope that my audience out there has learned some things. If you have any questions, feel free to contact either Mike or myself at our email addresses listed. And don't forget, the MSU Innovation and Commercialization Center is readily available at 606-783-9536. Thank you all, and have a great day. Good luck kicking off your Micro-ISV.